Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt, especially for this one. This is a Kropki Nabner loop. So loops can be fairly difficult, but obviously this probably is on the easier level. So take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Okay, so today's puzzle is, as I said, the Kropki-Nabner loop by Yitrio. And here are the rules. We have normal Sudoku rules apply, which means place the digits 1 through 9 in every row, column, and 3x3 region. We have to draw a 1-cell wide loop of orthogonally connected cells. The loop may not touch itself, not even diagonally. So as an example of a loop, so orthogonally connected means, so what does this mean actually? Let's talk about it this way. It means that I'm trying to go this way. This would be a valid loop because another way of putting it is I like to say that every loop on the every cell on the loop must share an edge with exactly 2 other cells on the loop. And if it shares a corner with a cell on the loop, it must be either its neighbor or it must share a neighbor, right? So these share a corner, they share a neighbor. That's why this is all a valid loop, because they each cell on the loop shares an edge with exactly 2 cells on the loop. And whenever they share a corner with another cell on the loop, they're either neighbors or they share a neighbor. What you cannot have, though, is something like this, because this cell, while every cell on the loop shares an edge with exactly 2 cells on the loop, these 2 cells share a corner, and they are not neighbors and they don't share a neighbor, right? These 2 are the neighbors here, these 2 are the neighbors for this cell. So that's why this is not valid. Also, you can't do something like, say, try to make the loop go like this, right? So it would go like this, at least for this rule set, because this cell shares an edge with 3 cells on the loop, and that's not allowed, right? Because it would be considered touching itself by going this way. Anyways, that's how the orthogonally connected loop works. Also, 3x3 region borders divide the loop into segments. Every loop segment acts as a Nabner line. That is, no 2 digits on a segment can be consecutive, regardless of their position on the segment. And a 3x3 region can have multiple segments, and single cell segments inherently satisfy this constraint. Okay. Yeah, I mean, that makes sense. So you could have something like, say, 2, 5, 9, and 7. And this would be valid because none of those digits are consecutive with each other. You don't have to worry about no repeats because obviously in a box you can't have repeats. So there's that. If this were, say, constraint here, well, obviously, that would be kind of a problem. But this is an example of how the Nabner line works in each box. Okay. For each dot given, digits separated by a white dot are consecutive, and digits separated by a black dot have a ratio of 2 to 1, and not all possible dots are necessarily given. So this is normal Kropki dot constraints. We have the Nabner already described, and we have the loop described, so now these are the Kropki dots. So for example, if this were, say, a 6, this would have to be a 5 or 7 to make sure that these digits are consecutive. If this were, say, a 4, this would have to be a 2 or an 8 to maintain the 1 to 2 ratio between them. And that's how Kropki dots work. And then finally, for each given dot, at least one of the digits touching the dot must be on the loop. So this is not a valid loop because for this pair, we don't have one that's on the loop. We don't have one that's on the loop here. Same with this, same with this. So for every pair of digits, at least one of the cells that the dot is touching must be on the loop. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay, well, because of the nature of the Nabner loop, you cannot, each of these pairs, one of these at least is on the loop. But the thing is, if it's this central one, the problem is it would have to go out through another loop here, right? You can only enter here, it would have to go here. But then by definition, these are consecutive. So that would not satisfy the Nabner line. So this can never be part of the loop. We'll mark that as blue, actually. And these two must be part of the loop. And to enter in and exit out, it has to be this way, and enter in to exit out, it has to be that way. So this can never be part of the loop because it would be touching itself, so neither can this. Okay. This has to exit out that way, and this must exit out that way. One of these is a part of the loop, and it could enter here, but it always has to exit out here. So this is always part of the loop here. So it could go here, here, and then here, or then here, here, and then here. So either way, it exits out this way. Same with these, right? This cell cannot, well, that's not true. It could go this way and then exit out here. That is possible. Huh. Okay. So this one could not ever enter in and then exit out because that was a problem there. Let's see. It has to be part of this loop. This one of these two cells must be part of the loop, so it has to go here, which means this cannot go this way. It could exit out that way. We don't know. Could also exit out that way. Could go this way, then that. So the problem with going this way is, it's the same problem here. The problem with going out this way is for 5-length Nabner line, which is the largest you can ever have a Nabner in normal Sudoku, right? Because to not have any consecutive digits, for 5 digits, it's 1, 3, 5, 7, 9. Well, try to add another digit there, and there's going to be a consecutive set. So that means if you have 6 digits on a Nabner, it's not possible. So, if you try to have a Nabner going this way, it's 5 cells, and they would all have to be odd. But this 1-to-2 ratio says that one of them has to be even, right? One has to be at least double the other, which is an even digit. So that's never going to form a valid Nabner. So it has to go this way as a Nabner, and it must exit out that way. This is not valid as a Nabner. This is not valid as a Nabner on the loop. This is not valid on the loop because it would touch itself there, because it would not share a neighbor, or they would not be neighbors here. Similarly, if this connected this way, this would form a 5-length Nabner with one of them being even, which is not possible. So this cannot be on the loop. It must go this way. This must go this way. This cannot go this way. It cannot connect this way because that's 7 cells on the Nabner line, which is not allowed. So this must exit out that way. This cannot go that way because it would be considered touching itself because they don't share neighbors and they're not neighbors. So this is not valid. Therefore, it must go this way. This must go that way. These cannot form a Nabner. So it must exit out back this way because these are consecutive. This goes this way. So it cannot go this way because it would be considered touching itself. Or because they cannot be neighbors because they would be closing the loop here, and we have one large loop here. So therefore, this cannot go this way. This has to go this way. So this is 5 in size. It must exit out that way. Cannot connect. This must exit out here. It cannot go this way because they're consecutive. It must go out here. This has to go out here and here. This cannot connect as a 7-length Nabner, so this has to go out here. This could potentially go that way. This cannot go here because that would be touching itself. Okay. So we know this Nabner is 13579. We know this Nabner is 13579. 579 cannot be on a ratio with 579 cannot be next to a black Kropki dot. So this is because 5, 7, 9 halved are 2.5, 3.5, 4.5, which are not digits. And if you double 5, 7, or 9, you get 10, 14, or 18, which are not digits. So we have a 1, 3, 1, 3 pair. That forces this to be 2 or 6 to be double that. This is 2 or 6 to be double that. We have a 1, 3 pair in row 2, which eliminates a 1 and 3 in the rest of the row. This cannot be 1 or 3. This can't be 1 or 3. So it cannot be 3, 6. It cannot be 1, 2. It's guaranteed to either be 2, 4 or 4, 8 in this for this white Kropki dot. So this is guaranteed to be 4 with 2 or 8. Okay. These digits are consecutive. We already have 4 odd digits in row 1. And if this was odd, that forces to be even, and that would be odd. So then that would be 6 odd digits in row 1, which is not possible. So this must be odd here. 1, 3, 5, 7, 9. Which, if you can't have 1, you can't have 9 here, because that's not consecutive with 2 other digits. If you have 5 here, you're guaranteed a 4 and a 6 here. If you have 3 here, you're guaranteed 2 and 4, and you're guaranteed that those are not possible. So this must be 7, which is consecutive with 6 and 8, which eliminates 6 and 8 in the rest of the box. So this cannot be 8. This becomes a 2, 4 pair. That eliminates 2 and 4 in the rest of the row, so this cannot be 2. This is 6, which makes this a 3 to be in a 1 to 2 ratio with it. That eliminates, this 3 eliminates 3 here, so this is 1 and 2 to be in a 1 to 2 ratio. So this cannot be 1, this can't be 1 or 7, no 1 or 7, no 7, 3, no 3, 7, no 3. Okay, remaining digits in box 1 are 4, 6, and 8. This can't be 6 or 4, so this must be 8, which means this cannot be 8 here. All the non-Nabner line is 2, 4, and 8, so this can't be 2, 6, or 8. This must be 4. That forces this to be a 2, 8 pair here. So the remaining digits in row 3 are all odd. Actually, all the remaining digits in box 2 are odd. So this 1, 3, 5, 9. This cannot be 1 or 3. If we have a 3 here, that would be consecutive with 2 or 4, so that's not allowed. So this cannot be 3 here. This is in a 1 to 2 ratio without a 4, so it's either 1, 2, or 3, 6. I'm not sure which. Okay. If we have this being 5 or 9, the problem is 5. So this would be a 5, 9 pair, which means you guaranteed 5 and 9 along this Nabner line. 5 is consecutive with 6, and 9 is consecutive with 8. So either way, that would eliminate all possibilities for the cell if this is 5 or 9. So it cannot be 5 or 9. It's 1 or 3 there. Okay. Well. Hmm. Okay, this cannot go this way because if it does, it would be considered touching that, and they're not neighbors. They can't share a neighbor because it's one large loop, not multiple loops. So this must go this way. Since it must go this way, these cannot be consecutive, so you cannot have 1 and 2 here. It's 3 and 6. And this can never be 5 in length. So if it goes this way, that would guarantee it's 5 in length as a Nabner because we have an even number here. Cannot go here, obviously, because it would be touching itself. So it must exit out. So it must exit that way. It cannot touch itself here. This must exit out that way. Cannot connect here. These are not on the loop. It could go this way. So 3 and 6. That means we can't have 2, 4, 5, or 7 here. One of these is going to have to be a 1. The other one can be 8 or 9 here. But we're guaranteed a 1 here. Okay. Remaining digits in column 9. They are 1, 2, 5, 7, 8, 9. 1 cannot be here. We are guaranteed in, where's the 1 in row 1? Cannot be any of these, so it must be one of these two. So this cannot be 1. Where's the 1 then in column 9? It must be one of these 3 cells, and therefore 2 cannot be here because 2 would be consecutive with it, and this Nabner line would not work. So where is the 2 then in column 9? It must be here. So this is 2. We are guaranteed an 8 here now because there's no other place for 8 in column 9. So 8 has to be here, which eliminates 7, 9 as possibilities. So this must be a 1, 5, 8 triplet, which eliminates 1, 5, 8 in the rest of the column. This can't be 5. This is a 7, 9 pair, which eliminates 7, 9 in the rest of the box. So this can't be 9. This is a 1, 5 pair, which eliminates 1, 5 in the rest of the row. So this is 3, 9. That eliminates 3, 9 in the rest of the box. This cannot be 3 or 9. This cannot be 3 or 9. 1 is consecutive with 2, 5 is consecutive with 4 or 6, 8 is consecutive with 7 or 9. This 1 to 2 ratio, it could be 1 here and 2 here. It could be 3 here and 6 here. 2 and 4 could work in any direction. 4 and 8 would have to be 4 here and 8 here. Okay, so those are the possibilities for that. Hmm. Okay. Remaining digits in box 9. We cannot have 1, 2, 3, or 6, so we have 4, 5, 7, 8, 9. Okay. Where is 3 in box 6? Cannot be here, cannot be here. It must be one of these cells, which means we cannot have 2 or 4 on this Nabner line. So this can't be 2 or 4. This is 3 then, and that's 6. We cannot have 1, 2, 3, 4, or 5, or 8. So we're guaranteed a 9 here. 2 and 4 are missing. No 1, 5. So 1 out of 6 or 7 is here and cannot be 6 because of the 6 in the column. So this is 7, 9 pair, which eliminates 7, 9 in the rest of the box. So this has to be a 2, 4, 6 triplet, which eliminates 2, 4, 6 in the rest of the column. So this can't be 2. This is 8, which makes that 2. That eliminates 8 as a possibility here. This can't be 9 as a possibility here because of the 7, 9 pair. 2 is consecutive with 1, 4 and 6 are consecutive with 5, so this can never be 8. Okay. What else do we have? So this has to go this way. It cannot go down because then that would have to necessarily connect that loop. So this has to go then this way. It cannot connect this way because this is 5 length Renband or Nabner line, which would be with a 6, and that's not possible. So it has to exit out. So it must exit that way. This must exit that way. One of these digits on the next to the Kropki dot has to be on the loop, so this must be on the loop. This is not on the loop. It must exit out that way because it cannot touch itself by going here. Cannot touch itself here. So this has to go all the way down here. Cannot touch itself. So it goes here. It cannot go here because these are consecutive. This must be a 5 length Nabner. So these are not on the loop, which means it exits out this way. So again, this is 1, 3, 5, 7, 9. And obviously 1 cannot be here. These are 2, 4, 6, 8. And 8 cannot be here. 1 is guaranteed to be one of these two. That means 1 has to be one of those. These has to be a 4, 6, 8 triplet. And that it does form a Nabner. This can't be 6 because of the 6 in the row. Let's see. This is 1, 2, or 3 here. Because we cannot have 4, 6, and 8 here. 5, 7, and 9 cannot be next to the black Kropki dot. So this is 1, 2, or 3. If this is 1, obviously this is 2. If this is 2, this could be 1 or 4. If it's 3, this is 6. It cannot be 6. So this can't be 3. This is guaranteed to have a 2 here. So it's either 1, 2, or 2, 4. That eliminates 2 here. So this cannot be 2, which means this can't be 1. This is 5. That eliminates 5 in the rest of the box. These are consecutive. Okay. Say you had a 2 here. If it's 2, you're guaranteed 7 and 9 here. The other 1 and 2 cannot be here, basically. So you can't have 1 or 2. But you could have 3, 5, 7, 9. Okay, this can't be 3 because of a 3 in the row. Oh, we have a 2, 4, 6 triplet in column 3, which eliminates 2 and 6 in the 2, 4, 6 in the rest of the column. So this is 1, which forces this to be 2. 2 eliminates 2 here, so it's 4 and 2. This can't be 1. Where is the 1 in box 7? It has to be here. So 2 is guaranteed to be one of these 2 digits, so this cannot be 2 here. We're guaranteed an 8 here, a 2 here. 2 has to be one of these 2 digits here. We're not sure which. Okay, so this is 2, 3, 5, 7, 9. Obviously, this can't be 3 because 3 in the rows can't be 5 because 5 in the rows can't be 2. Okay. This cannot be 9 here because if this is 9, that forces this to be 8, and therefore these would both be 1s. 4 cannot be consecutive with 5, so therefore this can't be 5. 6. 5 cannot be here because if 5 were here, that would be consecutive with 6. So 5 has to be one of these 3 cells. Well, 5 can't be here because that would be consecutive with 4 and 6, so that's not 5. It could be 5, 4, 3 here. That is possible. So 5 has to be one of these two digits here, so this cannot be 5. 7 cannot be here. Where is the 7 then? Because it's consecutive with 6. Where is the 7 in row 6? It has to be one of these two cells. So this becomes a 5-7 pair, which eliminates 5 and 7 in the rest of the box. This can't in the rest of the row, actually. Well, it couldn't be anyways, because this can't be 5 or 7. These can't be 5 or 7 because of the 7-9 pair here. So this has to be 2. So this is 2, which eliminates 2 here. Where's a 2 in box 6? It has to be here. What is the remaining, what has to be in this Nabner line? We don't have access to a 9 yet. So 9 has to be here. So this must be 9, which means 8 cannot be here. You could have 1 or 4 here, though. So this is 1, 4, 9. So this could be 5, 4, and 3. Or you could have 7, 8, and 9 here. And 7 cannot be here, so this would be 7, 8, or 9. Okay. We have a 4, 6, 8 triplet in row 4, which eliminates 4, 6, 8 in the rest of the row. This can't be 8. This is 1, which forces this to be 8, which forces this to be 4. So this cannot be 4. It's a 1, 9 pair. These can't be 4 anymore. 4, 6, and 8. That leaves the remaining digits as 3, 5, 7, 9. Okay, cannot be 9 because of the 1 9 pair in the box. Interesting. Okay. Remaining digits in column 4, because we have a 1, 9 pair, you can't have 1 or 9 here. So that leaves 3, 5, 6, 7, 8. Yeah. The 7, 9 pair eliminates 7 and 9 in the rest of the column. Okay. Okay, this digit cannot be here. So where is it in box 7? It has to be here. So this is 5 or 7. We know 2 has to be one of these digits here. Okay. This is 6, so that eliminates 6 here. So this is 8, which makes that 6. 8 eliminates 8 here, so this is 4, 5, and 3. Oh, this can't be 7, 8, 9 because of the 1, 9 pair there anyways. This can't be 3 or 5, so it's 7, which makes this 9, which makes that 7. 9 eliminates 9 here, so it's 3 and 9. 3 eliminates 3 here, so it's 9 and 3. 4 eliminates 4 here, so it's 6 and 4. 6 eliminates 6 here, so it's 8 and 6. That leaves this digit as an 8. This cannot be 5. This 3 eliminates 3 here, so it's 1, which makes that 9, which makes that 5. 5 eliminates 5 here, so it's 7 and 5. It can't be 1 or 9, so it's 3. 9 eliminates 9 here, so it's 1, which makes this 9. This can no longer be 1, so that forces this to be 1 here. No 6 or 7 here, so it's 3, 5, 8. This 9 eliminates 9 here, so it's 7 and 9. This cannot be 5 here. This becomes a 3, 7, 9 triplet, which eliminates 3, 7, 9 in the rest of the box. So this is 5, which means this can't be 5 and this can't be 5. Well, where is the 5 then in row 8? Can't be here because of 5 in the box. Can't be here because of the Nabner lines. Can't be here because of 5's in the column, so 5 has to be here. So this cannot be 5 here. One of these two is a 5. Remaining digits in column 5 are 4 and 6. Remaining digits in column 6 are 2, 7, 9. This can't be 2, though. Okay. 5, it will always be consecutive with 1 out of 4 or 6. And it has to go through this way to connect the loop. So this cannot go through the 5. It must go this way then. It could go here, or it could go here. Okay. These are even. This is an even digit. So again, Nabner line works here. 13579, 468, 13579, 13579, 158, 649, 7 by itself, 4 by itself, 315. This 5 eliminates 5 here. So this is 7, which makes that 5. 137 works, 196 works, 379 works, 4 by itself works, 7 by itself works. 158, 13579, 158. We still don't know this one. Okay. If it's 4646, this is 8 and this is 2. If it goes this way, though, this has to be 3. And therefore, this would be 6. This would be a 7-9 pair. That's interesting. Okay, if this is 2, so if it goes this way, this is 4646, which forces this to be 8 because 4 is consecutive with 3. So that would force this to be 3, 6, 3. That seems possible. 7979, which means this could not be 8. Right, so if we, well, it still could be 2, right? With 9, no. If it goes this way, yeah, the 7-9 forces this to be a 3. So it'd be 3, 6, 7, 9, 7, 9 in that case. Sheesh. These are a lot of, So again, if it goes this way, that's 4, 6, 4, 6. This is 8, that's 3, that's 6, this is 3. Which makes this 7. And this would be 2. And that seems valid. What happens if it goes this way? You're guaranteed a 7, 9 here. So this is 3. This is 8. So I think either way this has to be 7, right? If it goes this way, this can't be 3, so this is 8, which makes this 3. 6, 3, so that's 7. If this is going this way, this 7, 9 forces that not to be 8, so this is 3, that's 8, which eliminates 8 here, so this is 8, which is only consecutive with 7. So either way, this is guaranteed to be a 7, which eliminates 7 here. So this is 7's only consecutive with 6 or 8 here. We don't have a 3 anywhere else in row 8. So it cannot be here, cannot be here, or here. So this has to be a 3, which forces this to be 6. That eliminates 6 here. So where is the 6 in box 7? It has to be one of these two digits, which eliminates 6 here. So it's 4, which makes that 6. 4 eliminates 4 here. So 4 has to be one of these two digits, which eliminates 4 here. This 4 eliminates 4 here. Whereas the 4 then in box 9, it has to be here. So this is 4. We have a 7, 9, 7, 9 triplet, or pair in row 9, which eliminates 7, 9 in the rest of the row. So this cannot be 9. It's 3, which makes this 9. 3 eliminates 3 here, so this is 8, which means it cannot go through here, because then that would be 7 or 9 consecutive with 8. So it has to go that way, which means this is not on the Nabner loop. This has to be a 2. That forces this to be 6, 8, 2. Makes that 4, 2. 4 eliminates 4 here, 6 and 4. 8 eliminates 8 here, so it's 3. This can't be 2 or 9, so it's 7, which forces this to be 9, which forces that to be 7. 8 eliminates 8 here, so it's 1 and 9. This cannot be 9 or 7, so it's 5, which makes this 1, which makes that 5, and which makes this an 8. And let's just check to see that this is valid, right? 1 and 2 is a 1 to 2 ratio. 2, 4 is also 3, 6. 1, 2, 3, 6, 6, 3. 6, 7, and 8 are consecutive. 3, 4, 5 are consecutive. 4, 5 are consecutive. 7, 8 are consecutive. Each Kropki dot has one of its pairs at least on the loop. And 1, 3, 5, 7, 9 is not consecutive. 4, 6, 8 is not consecutive. 1, 3, 5, 7, 9 is not consecutive. 2, 4, 6, 8 is not consecutive. 1, 3, 9, 6 is not consecutive. 8, 1, 5 is not consecutive. 1, 3, 5, 7, 9. 1, 5, 8. 4 by itself. 3, 7, 9 is not consecutive. 1, 9, 6 is not consecutive. 7, 1, 3 is not consecutive. 7 by itself. 9, 4, 6 is not consecutive. That shows that this is a valid loop. Yeah, as I said before in the intro, I would put this in between easy and challenging because there's a lot of logic involved in this, and I don't think it's necessarily straightforward logic. So it's not quite challenging, but it's not easy either. Anyways, either way, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.